So here are the notes for chapter 9-3, the areas of trapezoids, rhombuses, and kites. Your objective is going to be to find the area of each of those shapes. You can be looking at your graphic organizer that has all the areas that you found already, and we will be reviewing that as we go through this section. First of all is a trapezoid. What's important to know about a trapezoid is that it has two bases. The bases are not always the top and the bottom. The bases are the two segments that are parallel to each other. They will never touch. The other two sides are slanted towards each other. Again, the height is always the one found by the right angle. So this is the formula that the book gives you, but the formula that I'm going to use is going to be the height times base 1 plus base 2, or the base sum. You're adding two bases together, and then instead of taking 1/2, you can just divide by 2. So for the first example, just watch. This is the map of Nevada, but it's just an estimation. What is the approximate area of Nevada? It's the trapezoid, but see, like I said, the bases are not always the top and the bottom. The bases are the two segments that are parallel, that would never touch each other. So I'm going to start off with the formula. The area equals the height times the sum of the bases, and then we're going to take that and we're going to divide by 2. So starting with the height here, the height is 309. I know it doesn't look like the height because it's going sideways, but yet that's the segment that is perpendicular to the two bases. So the height is 309. The bases are 205 and 511. You add the two bases together because these two are parallel, and then you divide the whole thing by 2. So doing this in your calculator, I'm just going to add inside the parentheses first 205 plus 511, and then I'm going to take that number and I'm going to multiply it by 309 times 309. And I'm going to take my answer and I'm going to divide it by 2. So my answer is that the area of Nevada is about 110,622. 110,622. It's in miles, and it's area, so I'm going to say miles squared. So here's the first one for us to do together. Go ahead and look at your notes. This one's printed for you. What is the area of a trapezoid with height 7 and bases 12 and 15? You can draw a picture if you want. In this case, we don't need to draw a picture. We can just go with the formula. The height times the bases, the sum of the bases put together, and then divided by 2. So in this case, the height they told us was 7. So I'm going to plug that in. 7 times the two bases together. The bases in this case are 12 and 15. So those are my bases. So I'm going to say 12 plus 15, and I'm going to divide by 2. That equals 7 times 27 divided by 2. You can do that in your calculator. 27 times 7, and then divided by 2, you have 94.5. The area equals 94.5, and they tell me it's centimeters, and since it says area, I'm going to say centimeters squared. So the trick is to remember to add the two bases together, multiply by the height, and then divide it by 2. Okay, so now it's time to try number 1 and number 2 on your own. Hit pause, try these problems using the formula. Area equals the height times the sum of the bases, and then divided by 2. And then when you're done working those out, hit play again and check your answers. Okay, so your answer for number 1 should have been 144.5 centimeters squared. If you didn't get that, let's look at this. The height is 8.5. That's the one that's perpendicular to the two bases, and the bases are 24.3 plus 9.7. They're the ones that are parallel to each other. This one never touches this one. And then we're going to divide the whole thing by 2. So in your calculator, you have 24.3 plus 9.7 equals, and then times 8.5, and then take that whole answer and divide by 2. And you get your 144.5 centimeters squared. Okay, so for number 2, you should have had 108 feet squared. In this case, the bases are on the left and the right. Those are the two sides that are parallel, and the height is 9 feet perpendicular to the bases. So we're going to say 9 times the 18 plus the 6. And then we're going to take that whole thing and always divide by 2 for triangles and for trapezoids. And with that, we're going to get 18 plus 6 is 24. And then we're going to multiply by 9. And then we're going to divide by 2. And you get the 108 feet squared. Okay, now these are two different shapes, the rhombus and the kite, but they have the same formula here. D stands for diagonal. The diagonals are the segments that start at one corner and go to the opposite corner. I'm going to rewrite this formula as diagonal 1 times diagonal 2, and then we'll divide the whole thing by 2. I just think that's easier than dealing with the fraction. So for a rhombus, diagonal 1 is all the way across this way, and diagonal 2 is all the way across this way. For the kite, diagonal 1 is here, diagonal 2 is here. Now what makes a rhombus is that all 4 sides are equal. What makes a kite is that the two sides next to each other, the consecutive sides, are congruent. These two sides are congruent and these two sides are congruent, but all 4 of them are not. So those are the shapes where we're going to use this formula. So look at this first example where you just watch. It's not written out for you. This is a kite, K-L-M-N. Okay, so finding the area of the kite will require the area is diagonal 1 times diagonal 2 divided by 2. So it doesn't matter which one you consider diagonal 1 or diagonal 2. You just have to include both. So this green segment will be diagonal KM. And this piece is 2, this piece is 5, so diagonal 1 all the way across is 7 meters. This one right here, happens to be from top to bottom, is going to be 3 and 3. This piece is 3, this piece is 3. So diagonal 2 is going to be 3 and 3, which makes 6. So in my formula, I'm going to say 7 times 6, the two diagonals, and then I'm going to divide by 2. 7 times 6 is 42. 42 divided by 2 is going to be 21, and since it's area, we're going to say 21 meters squared. Okay, so this is another one that we should do together, finding the area of a kite. What is the area of a kite that already has diagonals 12 inches and 9 inches long? So you don't really even need a diagram for this one either. You just take the formula, area equals diagonal 1 times diagonal 2, and you divide it by 2. Diagonal 1 is 12, and diagonal 2 is 9. So we're going to multiply diagonal 1 times diagonal 2, and then we're going to divide it by 2. So 12 times 9 is 108. And then when we divide by 2, we will get 54, and it's inches squared. Inches squared. So here's some for you to try on your own. Find the area of this kite. You are going to use area equals diagonal 1 times diagonal 2, and you're going to divide by 2. Remember that the diagonal will go all the way across. This is one of your diagonals, and this is your other. And for the last example, it's a kite. So this is one of your diagonals right here, and this is your other. Okay, so for number 3, you should have gotten an answer of 80 inches squared. In this case, diagonal 1 goes all the way across. That's 8 and 8. That makes 16 inches. And diagonal 2 goes from top to bottom. If you add the two parts together, 2 and 8, you get 10. So your area is going to be 16 times 10, and then divided by 2, that's 160. Divided by 2 is 80 inches squared. For number 4, you should have had an answer of 18 meters squared. That comes from area equals diagonal 1 times diagonal 2 divided by 2. Diagonal 1 from left to right is 6, and diagonal 2, it doesn't matter which one you call which, but top to bottom is 6. So we're going to do diagonal 1 times diagonal 2 divided by 2. That's 36 divided by 2, or 18 meters squared.